Good morning, Chem 20s. Our lesson today is going to be on preparing a standard solution from a solid. We're going to continue from the example you've already seen the calculations for, and that is we're going to prepare a solution of copper 2 sulfate pentahydrate, and we're going to make a 100 milliliter solution at 0.186 moles per liter. You've already seen me do the calculation, so you know I'm going to have to measure out 4.64 grams of my copper 2 sulfate solid. So let's get started. I'm going to turn on the scale. And what I would like is to put on some weighing paper, but I don't want my weighing paper to have any mass. So I'm going to tear my scale, and now we're going to put on 4.64 grams. And I don't want to spill anywhere other than on this paper because we want to get a very accurate measurement because we are making a standard solution. So again, we're going for 4.64. Getting closer. And you can remove if you're gentle about it. Okay, we have our 4.64 grams. What I'm going to do now is I'm going to take this 4.64 grams and I'm going to transfer all of it into a beaker. Because we're making 100 mils of solution, I'm going to take distilled water and I'm going to just take the lid off here. And I'm going to pour half the amount of distilled water into my solid crystals of copper 2 sulfate. So because I'm making up 100 mils, I'm going to pour in roughly 50 milliliters of water. And what I'm going to do is I'm going to stir this. And I'm going to break this up till all of my crystals actually dissolves. Now, we have to be careful at this stage because if at any stage we stir too vigorously that we splash, I am no longer making up my solution to 0.186 moles per liter. If I lose some crystals by a splash, I'm not making a standard precise solution anymore, so I have to put this in the waste bucket and start again. If I at any time when I'm done stirring lift out my stirring rod and set it on the desk or on my cafeteria tray, you will see that some solution has made it onto the tray. Therefore, I might have taken some solute with me, and again, I would have to start again. So this is probably the most important stage whereby we are just kind of gently stirring, getting all the crystals to dissolve. Now, I'm not going to make you watch me dissolve crystals, so I'm going to pause the video and I'll come back when my solution's already dissolved. So I've completely dissolved my copper 2 sulfate solution, as you can see, and I've left my stirring rod into the solution. My next step is going to be is I want to transfer all of my solution into my 100 milliliter volumetric flask. Now, this is called a volumetric flask because it has a neck, flask neck. And so we've looked at other flasks before, but what we'll notice is a beaker is not a precise piece of equipment. A flask is, and the reason a flask is a precise piece of equipment is, if you can see right here, there's only one mark on this flask, and that line shows us when we are at the 100 milliliter calibration line. And so what you're looking for is, if this is my line right here, what you're looking for is the bottom of your liquid, the bottom of your meniscus. That's what this rounded spot is. You want it to just touch that line. That represents 100 mils. Too little, and you don't have 100 mils. Too much, and you have more than 100 mils, and there's no way to pull out only water when this solution has already dissolved. Therefore, if you fill past that line, you have to dump this in the waste bucket and start again. So the key to this is pouring this in here without spilling. You can use a funnel if you would like, but that's just one more piece of equipment where you could lose some of this copper 2 sulfate solute. So I'm going to pour this gently, and you don't have to go very fast. Now, once it's in there, the reason we left some of the water out, half the water out of this when mixing was because now we have to rinse this equipment off and get every little particle that might still be left on the stirring rod or in the beaker. So first thing I'm going to do is I'm going to rinse the stirring rod. I rinse it really good. Now, when I set it down over on the side, I know I have taken all the copper 2 sulfate off of it and put it back in the beaker because I've rinsed it. I'm also going to rinse the beaker, make sure it all moves over, and I'm going to transfer my rinse water into the volumetric flask as well. And you'll notice I have room to rinse it a few times. So I can make a point of making sure every single copper 2 sulfate particle has made it into this volumetric flask. Now, perfect. Now, I am still not at the calibration line. If you can see the line, I'm a little bit below it. So what I can do is I can put some distilled water into another clean little beaker, and I'm going to fill it up to the line using an eyedropper. You could also use a disposable pipette. Now, what you want to do in order to do this, though, is get down to eye level so you can really see the meniscus, the bottom of the meniscus on that 100 mil calibration line. So I'm going to get right down there. It is again at this time, if you have any bubbles, you can just gently knock them out. If there's any bubbles on the side, I'm chasing them up to the top because we want to make exactly 100 milliliters. Probably one more. Perfect. So what I have is I now have my solution perfectly so the bottom of the meniscus is on the calibration line. I'm going to stopper this, and it's hard to see, but it's exactly on that line. And then what I'm going to do is I've stoppered it, and I'm going to invert it a few times. I'm going to allow the natural air bubble that's in here to mix this solution. Because remember, the bottom was the copper 2 sulfate solution, and all this was distilled water. So I'm going to mix it a few times. The one thing we never do in chemistry is we never shake a reaction because we don't know how exo or endothermic it's going to be. And so it could react quite violently. And now I'm going to take a clean, dry beaker. And so I'm going to make sure this is dried out. And I'm going to put my solution in here. I never use a beaker that's not dry because, again, we just took the time to make a 0.186 moles per liter solution. If I put it and there's even a drop of water in here, it's not at that concentration anymore. On that note, if I was now to look at my solution after I inverted it, again, it'll look a little bit low, the volume. Do not add more water. When we first did it, it was perfect. We had it on the calibration line. Now that I've inverted it, there's a drop or two stuck up here or stuck on the bottom of the cap. Please don't add more water, right? The concentration is the same. I might not get out exactly 100 mils, but I made this solution because I only probably needed 90 or 95 mils. I always make more than I need because I know I'm going to lose a few drops on the lid, or when I pour it out, some will still stay in the container. I won't get all 100 mils. So I'm just going to pour gently, making sure to get as much as possible. Now again, I can still see that there's a few drops in there. I'll never be able to get them out, but because it's been mixed thoroughly and it's homogeneous, because we made it to a certain concentration, the whole solution is now 0.186 moles per liter concentration. So this is our solution that we have made.